Welcome to today's episode of Tech Talk, where we dive deep into the fascinating world of memory safety and code execution. If you've ever wondered how we can run potentially unsafe code without causing chaos in our programs, you're in for a treat. Let's kick things off with a magic trick known as mem-isolate. Now, if you've ever experienced a program crash or memory leak, you know how frustrating that can be. What if I told you there's a way to run functions in a process that's completely isolated? That's where mem-isolate comes into play. It allows developers to execute code in a forked process that won't impact the parent process at all. Fascinating, right? Picture this. You want to run some code that you suspect might leak memory or cause a segmentation fault. Normally, that risky move could bring your entire program crashing down. But with mem-isolate, it's like having your own little safe zone. It takes a snapshot of your program's memory right before it executes, allowing the risky function to run while keeping everything else intact. Imagine taking a picture just before a roller coaster ride. You get to remember the fun without worrying about the possible mess afterward. So, how does it work? Well, it's all thanks to something called the fork system call, which creates a new child process. Think of it as making a perfect copy of your program at that moment in time. Both processes share the same memory pages. But here's the kicker. Any changes to the memory pages by the child process don't affect the parent. If the child has a meltdown, the parent remains unaffected, like a superhero protecting its city from disaster. Now I bet you're wondering, what's the downside? Well, it does come with some overhead, of course. The process is a bit slower than direct function calls, taking somewhere around 1.9 milliseconds on average. It's like driving through a scenic route instead of taking the shortcut. It takes a bit longer, but the extra safety and peace of mind might just be worth it. Let's not forget the serious side of things. With mem-isolate, we can even isolate functions that rely on external, potentially unstable code, such as calls to C libraries, which can be a real headache in the programming world. This way, developers can experiment with unsafe code while ensuring their main application runs smoothly. Talk about a win-win. Now let's shift gears and reflect on some real-world applications. Can you think of scenarios where this would be invaluable? Maybe when integrating third-party libraries, or even when executing user-generated code in applications. The possibilities are vast. To wrap things up, mem-isolate is a groundbreaking approach to tackling memory safety issues. By isolating code execution in separate forked processes, it gives developers a powerful tool to maintain stability without sacrificing functionality. As our coding landscapes grow more complex, innovations like this are not just advantageous, they're essential. So next time you're grappling with unsafe code or worrying about memory leaks, remember that there's a safe zone waiting for you with mem-isolate. Thanks for tuning in today. Until next time, keep exploring the tech world. There's always something new to learn.